Alright, so first we start with the question. And the question is 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 moles of calcium hydroxide. What was the concentration of hydrochloric acid in the original solution? We should then balance out the equation as we did here, and then we're going to draw up a picture. And here we have a 75 milliliter solution of hydrochloric acid, and we're adding in the calcium hydroxide. And as you see, we have our 75 milliliter solution of hydrochloric acid, and we're going to add in our calcium hydroxide. And this gives us an end product of calcium chloride plus H2O, and we need to find the moles for hydrochloric acid. So what do we already know? We are given that our hydrochloric solution is titrated with 27.3 milliliters of 0.157 moles of calcium hydroxide. With this information, we can calculate how many moles of calcium hydroxide we have. Then we can calculate from there how many moles of hydrochloric acid are in the original solution. We first convert from 27.3 milliliters to liters and multiply that by the moles of calcium hydroxide, which is 0.157, and that gives us 0.00428 moles of calcium hydroxide. After that, you must remember your mole ratio in the solution, which is 1 mole of calcium hydroxide to every 2 moles of hydrochloric acid. With this information, we can now calculate the amount of hydrochloric acid in the original solution. And to do so, we multiply the moles of calcium hydroxide by the mole ratio of hydrochloric acid to calcium hydroxide, and that gives us 0.0856 moles of hydrochloric acid. Then you would divide by the original starting amount of solution, which is 75 milliliters converted into liters. Lead us to 0.0856 moles divided by 0.075 liters, which would equal 0.114 moles of hydrochloric acid. And some common mistakes are not adding the mole ratio to the equation.